Now we are solving this problem known as scheduling with the deadlines, and we are solving this. This comes under greedy problem. So okay, let's start. Now let me tell you first what this scheduling with deadlines job is. Here, here we have a list of job. Here we have a list of job, job one, job two, and so on. Along with these jobs, a deadline is given as well as an associated profit is given. Now if we complete these jobs either before this deadline or at this deadline, then we will generate the associated profit. So let's start solving it. Solve. Step 1 is simple. Sort the jobs. Based on sorting will be done on the based on profit, that is high to low. Now we are giving new index for each jobs 1 2 3 4. Here here we have profit associated because we are sorting with the profit, so 40. Then we have 35. Then we have 30, and then we have 25. So let's write old job id and deadline. So with 40, the deadline is 1 and the old job ID is 4. With 35, deadline is 1, old job ID is 2. With 30, deadline is 2 and old job ID is 1. With 25, deadline is 2 and old job ID is 3. Now what we do? We will initialize. At initialization, we will keep track of jobs using an array. In the first, let's take first job. So, and here we will write the size of the array p is 1. Now this with first job, old ID is 4 and profit associated is 40. Then there comes it initialize 1 means I is equal to 1. Now there comes I equal to 2. There is iteration 2. So we have a proposed set k. So in previous one we are taking 2, and this 2, old ID was 2 and profit associated with 35. Okay. Now this one job will have, so in slot 1, job 1 have deadline 1. Okay, this old job has deadline 1. Then we have 2, this old job slot 2, job 2, this had the deadline 1, So here we can see that there is a conflict. After when this k, in k, when the array size was 2, so we will write p equal to 2. So as here is a conflict, therefore j will remain as 1 and hence p will become 1, because in the same slot we cannot keep the two jobs. Okay. Now I equal to 3, this means iteration 3. Then we have proposed set k. Inside k we will add 3. So old job ID is old job ID of 3 is 1 and profit associated was 30. All right. So in slot 1, job 1 requires job 1 have deadline 1 and job 3 has deadline 2. So we can keep this in slot 2 because each job takes only 1 unit of time. So this job 1 will execute in slot 1 and then we can start job 3 which will also take 1 unit of time, and we can put this in slot 2. So no conflict. Therefore j size will become 1 comma 3, and hence p size will become 2. Then we have I equal to 4, or we can say that iteration 4. Then proposed set k will become v1 3, then 4. So old job id is 3, and profit associated is 25. All right. So we can put in slot 1 as job 1. Job 1 will have deadline 1. Okay, no problem. Then we have job 3. Job 3, it has deadline 2. Then we have job 4. Job 4 has deadline 2. Job 4 has deadline 2. Now we can see that these two jobs are creating a conflict. Therefore they are not feasible. Here also it was conflict, so not feasible. Therefore j size will remain 1 comma 3, and hence p size will remain 2. Now we can calculate the profit. Profit will be job 1 profit plus job 3 profit. So job 1 profit was 40 and job 3 profit was 30. So we have total profit is 70, and this is our answer.